Hello and welcome back to the Accedo Playback Podcast, the podcast discussing industry news, trends, and tech advancements in the OTT and streaming industry. I'm your host, Neil Van Zyl. AI has lowered the barrier to building streaming software. If you have the conviction, the resources, and the roadmap, the case for building has never been easier. But there's a pattern that keeps emerging in practice. The first 80% comes together quickly, but the remaining 20%, that's where streaming services are actually won or lost. This turns out to be a bit of an expertise problem, not an engineering one. And AI doesn't solve expertise problems, it democratizes the floor, not the ceiling. In this episode, Daniel Eneström, head of engineering for Europe and Latin America at Accedo, and Daniel Astudillo, head of engineering for North America, get into what the gap actually looks like from the inside, where AI-assisted development creates genuine leverage, where it creates false confidence, and what the compounding cost of getting the hard parts wrong looks like over time. Daniel E. and Daniel A., welcome. Thanks for coming.
Thank you.
Thank you.
Let's get right into it. Okay, Daniel E., AI has genuinely made building streaming software easier. From where you sit in Europe, what has actually changed in the last 2 years that makes that true?
Well, 2 years is a really long time in this space. I would say that the models have become smarter, of course, but that's not really the big differentiator. I think the big change is that the models stopped guessing as to what to do. Before 2 years ago, if you asked it for something, the output was kind of an average of everything that it had learned from the internet. While as now we have integrations with actual tools. It knows the actual context of the code base. It has connections to Figma for designs. It had connections to Jira for information on what to do. So I would say the biggest change really is context. And our capacity to steer it and control it in a way to make it produce proper output. So that makes quality higher at the end.
Yeah, I believe it was late 2024 when Anthropic open sourced the MCP standard, which is obviously just revolutionized what LLMs can do. It's just really jumped things to the next level.
Yeah.
Daniel A., so at Accedo, we've previously made the argument that AI gets everyone the same 80% point. But you're using the same models, the same tools, and obviously you're starting from the same place. Does that make sense to you? Is that what you're seeing in practice?
Well, yeah, the 80% point actually holds, but the biggest caveat here is that 80% is it gives you the confidence that you're building something. It compiles, it looks good, but since now that 80% is democratized, like that 80% is the bare minimum that you can do. So that 20% is where the differentiator with other companies, with other streaming services is. So that 80% is just matching like the existing basic, and it's not like the long-term goal. That 20% is what you build and differentiate with. So the hard part, it hasn't even started yet when you reach that 80%.
Well, that's a good point there. So then, does the use of AI in development make it feel for teams like they've solved the hard part when they actually have just reproduced the same sort of patterns?
Yeah. Can I pitch in there too? I'd like to add something else. I think the 80%, yes, it's true. It resonates that it's the same baseline essentially. But it isn't really, because looking at studies show that building code with AI increases number of security vulnerabilities, for instance. It also increases duplications of code. GitClear made an analysis of like a large number of repositories and discovered that there is a 4 times increase in the duplication of code in the past 4 years, presumably by AI development. And there's a last thing, which is maybe the most important. Anthropic made also a research study that showed that 17%. There's a 17% lower comprehension of what you actually built from the engineer side. So even though you have built the 80%, sure, if you build 80% The same 80% in the traditional way gives you a product that you can change and work on. But those 80% using AI gives you a product that you can only add to, but necessarily not change because you don't have the comprehension, right? So I think that's one of our key challenges, not only those extra 20%, but also for us as engineers to make sure that those 80% are secure and stable, of high quality, and that the engineers understand what they're building. So it's kind of a yes and no answer to that, I think.
And I think the two of you would have a great perspective on this, but I'm sure review times have also gone up, right? Because people are pushing, they might be pushing faster, but now you're, like you said, if you don't have the context on what was built, you're coming into this a lot in the dark, and then you're just spending a lot more time reviewing, trying to understand what was even built in the first place, and especially from the engineering lead position where you have to try and make sure that everything is at least a certain level of quality.
Exactly. We are producing a lot of code, a lot of text, a lot of. Usually, the PRs are now three or four times longer than before. So the people that have to review the PRs have to take more time just to read the code and stuff. So yeah, you are producing more code, but sometimes, as Daniel mentioned, the quality of the code is not the same, and we have to have better guardrails and like guidance for the agents to produce better code, better PRs, and better content in general.
Daniel E., you've spent a lot of time thinking about what expertise actually means in this context, right? So we've said that even though I know we kind of agree to disagree about where the 80% line lies, but if the first 80% is essentially a bit more of a pattern matching problem, and does the 20% at the end there really become more of a judgment problem? Like, where do teams still need the human expertise to decide what good actually means?
Let's unpack that, because judgment it's a tricky word, right? What does a judgment actually means? I mean, judgment is really the accumulation of expertise, really, right, and experience from our 20 plus years of working with these types of tools, and that's where we make a difference. So how do you then break that down into the value that we actually bring? So I think, yes, it's about judgment, but what does judgment mean, and how can we harness that judgment and deliver that as value, right? And I think this is not just for us, but for any company using AI in their development. That's going to be the key challenge, I think, going forward. How do you provide that judgment in decision making when building it with AI? So it's a it's a convoluted answer, but it's really hard, because I think we need to start thinking about, we can't provide judgment to an AI, for instance, but we can produce the artifacts of judgment to an AI. We can start harnessing the experience and the expertise we have in a way that we can provide it to an AI to also help us in those last 20%. But I think that's a few years down the line to do that properly. But I think that's the challenge going forward. So far, this is really where humans make a big difference. And I mean, that could be anything. Like, even though an AI might have all of the context it needs, all of the product requirements it needs, there are still situations where a human would be able to say, okay, this particular view is consumed by an individual using a phone and experiencing this in a certain way, while this other view is used in a sofa watching a TV with a remote control. And what are the decisions that we make in designing this experience based on those scenarios? I don't think AI is mature enough to do those kinds of judgment calls, right? And that's where I think humans are necessary.
Yeah, I guess it comes back a little bit to a bit of life experience in a way there. Daniel A., there's a phrase we often use internally, right? Accumulated expertise earned over hundreds of deployments. What does that actually mean in practice?
Well, yeah, you have to think, as Daniel mentioned, that AI is very good at doing stuff that is predefined. For instance, there are billions of websites, so AI is very good at creating websites. There are millions of Android apps, so AI is very good at building Android apps and stuff like that. So if something is very common, the agent is more effective in building that. But usually, like streaming platforms, like the ones we work on, they are not common. They are like it's a complete system. You have apps, you have services, you have integrations, you have all of these working together. So, for instance, I remember a case that there was a set of front-end apps that we built. You had the middle layer, and at some point, just when a huge live event was happening, the identity service goes down. What happens? Like everything starts falling down. All of the systems start interacting, all of the errors start broadcasting between all the systems. And we have seen that a lot of times with different systems, with different clients. So understanding what happens with those extreme difficult cases, and that's kind of the expertise that we have and we bring, and we are working into how to encode this expertise into something that the agents can use to actually build something more robust in a general system.
And I think you bring up an interesting point there as well, because a lot of the times, some of the stuff we're doing is completely nascent. For example, as the OEMs start to add more base OS level integration functionality, I mean, Samsung with Samsung Checkout, or even some of the new voice remote functionality, these are things that are not publicly available and might not have any sort of documentation around it. So this becomes a bit of a new frontier. That's a I'm curious, do you feel like that is somewhere where, even though there might not be a lot of available information that AI would support, or do you think that's where the human layer needs to come in again?
Yeah, so right now the human layer is the connecting layer between the agents. Because as I mentioned before, we are building systems, a lot of different things connected. And AI agents are very good at taking one system that you know the inputs and outputs, and like building on top of that things that it already has context. But these interconnected systems that only the humans right now have more context than the AI agents, encoding that knowledge is the work that we have to leverage the power of AI and being able to build these systems and interactions in a better way.
Daniel E., obviously, when building OTT applications, these can be rather quite large services. And if you have a full team working on it, you have a lot of resources pointed towards one component. How do you manage context in these sorts of approaches if you have to also include an AI system, right? Is everyone working via one tool, and how do you kind of manage that?
That's the question, right? I see multiple ways of solving this. We have been experimenting with versions where we have sort of a collective brain that everyone can connect to. Um, we have projects where we've been very successful with actually having automations that save the requirements, things like PRDs, right into the repositories of each of the platforms so that they all share sort of a common source of truth. But with automation, these files are copied into the repositories as they are updated and added from sort of a single location. So that all of the AI agents working in the repositories themselves always have this up-to-date context right in the repository. That's my favorite version of it right now. But I know that Daniel is working on other ways of giving this knowledge and sharing between AI agents, right?
Yeah, and I think that the biggest challenge right now is not only like what's the way of delivering the context and the memory to the agents, but also knowing what to include in the memory, because for instance we have a lot of like established players, big companies, big streaming services as our clients, and they have a lot of history, a lot of baggage in their repositories, in their Confluence spaces, and whatever. So more context not always equals better context. So you have to start dealing with uh, old information, deprecated information. The same source code sometimes have old business logic that you right now you don't want to include in the new systems. So also tuning the harness to kind of take the right information from the context is a lot more important for bigger customers.
Yeah, and that will become even more important as tokens become more expensive. As the market looks now, token economics is definitely something we need to be mindful of, because just a year ago it was all about send all of your context in, as much as you want, to give a full picture to the agent, and now it's all about, as Daniel says, about refining the context to be specific, and just give enough to get the quality and the output that you need, right?
Yeah, there's a lot more we can talk about there, and I want to get into harnesses and even potentially about how you evaluate frontier models versus open source, obviously, as you try and control your data layer a little bit more. But before we do that, Daniel E, you've written a technical paper which is going to be released at IBC in a few weeks. Without giving too many spoilers, what's the core problem it focuses on?
Well, I saw a lot of conversation at the time. So this is a few months old now, the tech paper. It's already becoming old news, I'm afraid. But a lot of the conversations have been about, should we build with AI, essentially. And how much can we build with AI, and how fast can we build with AI? And what I wanted to challenge there is rather, I think it's a given, it's kind of settled that we are building with AI now. That's the new normal. So how do we ensure quality? And how do we make sure that we don't have those security vulnerabilities and things that I mentioned before, so that those 80% that we talked about are actually up to par, right? So that's what this research paper is testing, how we can get that quality, measuring in various ways, by by you know by putting in the correct guardrails and sort of the correct context and the correct commands, to have AI produced code that is on par with the manually produced code quality wise, really.
It still sounds pretty relevant to me, I think. Daniel A, so you mentioned harnesses briefly there. When you think about an effective agent harness, what matters most? Is it what the agent can see, how the context is retrieved, how outputs are evaluated? What are your thoughts?
So I like to always think like what is an agent like from the base, right? And an agent is a probabilistic machine. So the biggest lever that you have over the output of a probabilistic machine is what you put in, like like the input. Good inputs are better odds. If you have bad inputs, you are actually gambling to get a good result. Um, so in the context of a project, you have a lot of information. Like you have too much output. So at the end, you have to kind of slice your development process into different sections, like let's say requirement gathering, UI, UX definition, architecture and system design, planning, development, QA release. Like each of those slices, you can have inputs and outputs. And the idea is like you measure the output on each one of the phases. And obviously, if you have a weak output in a phase, you can directly map it to a weak input on that same phase. So for your question, what's the most important part right now for me in a harness is the inputs, and that is context, memory, instructions, and tools, and especially tools. because one of the things that the agents are very good is taking information, processing it, and giving an output. But right now, we have a lot of constraints on what the agent can do, on what the agent can see. And I like to use the phrase giving hands to the agents. We have built some systems, for instance, that give the agents access to devices, to cameras, to different network protocols to be able to actually test what they are building on the real devices, on real networks, on real hardware, and that improves the output of the agents like by tenfold. So yeah, my answer at the end is inputs. But inputs is a lot of things: context, memory, instruction tools.
Daniel E, anything to add?
When it comes to a harness, as I mentioned before, I think how the harness works with context will be important going forward. And I think that's one of the big strengths with Claude, for instance. Claude has been, proven to be so successful because what's happening under the hood, I think, because at surface level, Claude and using Copilot or Claude or Codex works the same, right? And where Claude has been successful as a harness is really what it does with the context, as you say, Daniel, with the inputs, and how it manages data, essentially. And I think that's where we need to be even more mindful if as the context or the tokens becomes more expensive.
Yeah, obviously we're right now. I think tokens are a little bit subsidized, so everyone is getting the benefit of build fast and build as much as you want. But as we shift towards the as we shift towards the future, the economics are going to come in and prices are going to have to scale. How do you see, I guess, balancing both the quality of frontier lab based LLMs versus open source tooling? And do you think I guess the future is to blend them both and to have the right harness that handles the approach when you're deciding which to use? Or what do you think there?
I would say yes. I would say a hybrid approach is the future. That's actually one of the things I like about Copilot is that you can use the frontier models, but you can also sort of hook in your own, even locally hosted models, which is something I think we will have to be able to do going forward for any tool that we use. I foresee a future where the more senior AI engineers work in maybe Claude or something similar, spending their tokens with these expensive frontier models, really planning out the work, but then handing off the actual execution to open weight models running somewhere else, maybe in a cloud harness service, to do the actual work. Something like that, I think, is probably the future.
Daniel A, any thoughts to add?
Yeah, I agree. We have to be able to use the better harnesses that we have, like Claude, for the more valuable tasks, and use like open source models or like our local models for like the grunt work, right? It's like and in that sense, a harness that also is able to use multiple agents, multiple harnesses below it, um, a better orchestration layer of the agents is something that we must try to improve in our processes, because I think that's going to be the deciding factor if you're going to be successful or not. Like how to use the expensive models, like the cloud models, that have a lot of power and a lot of reasoning, and then just leaving the easy work to your local machine, so you can just get the final results there.
I agree, and I think I just want to sort of I want to mention collaboration a little bit. I think that's something that keeps being left behind. Working with AI today is a lot about one engineer working with AI or multiple agents. and another engineer working with their agents, but there isn't a lot of collaborative work when it comes to AI. And I think that's something we need to be better at. And I anticipate they're coming out new tools. Maybe, the big ones, Anthropics, maybe will launch new collaborative ways of working with the models. Who knows? But I think that's really a key thing for those 20% where the judgment is necessary. We need to be able to collaborate around how we work with these AI models, and that's not really possible today. So maybe that's also an avenue where the open weight models can come in, and we can use some other collaboration tool that makes use of open weight models for collaborative work. So some prediction there.
There's a lot of money to be made for the first person to properly set up the Google Drive or the Dropbox equivalent that allows you to interact across an LLM.
Yeah.
I want to hear from both of you on this one, but I'll start with Daniel E. Is there a version of this where a streaming platform uses AI assisted development well and builds something genuinely differentiated, or does the democratization argument mean that it's a shared ceiling always?
uh, well, there is a shared ceiling, but I think the differentiation isn't doesn't come from the AI itself. It's more about what you do with the time you save, right? AI gives back time, essentially. That's what it does. And what you spend that time on is kind of the choice you make. And I think many teams don't even realize that they're making that choice. It's kind of the default is to cash out in time. Oh, we delivered 2 months early with this, while another team might take those 2 months and improve the performance on those low performing devices that they had sort of deferred to the future, or improve accessibility, or the download performance on the offline playback for the mobile apps, whatever. Those things that you typically put on hold because you don't have time before a deadline. If you focus that save time on that, you would end up with a higher, better quality application rather than just saving time. So that's where I think the differentiator is in this, right? It's not only about saving time, which a lot of the dialogue is about efficiency, and I think it's not the whole truth. So yeah, that's I think it's. I don't think that people choose a streaming service because of being able to deliver a month early or two. I think they choose a streaming service based on the quality of the output, or the trust in the team, or in your capacity to deliver something that your end users will really enjoy. So I think there's still room for differentiation, even though AI definitely sort of democratizes it to some extent.
Daniel A, anything to add?
Yeah, well, just mostly agreeing with Daniel. So yeah, with the democratization of the development, so the bottleneck moves up the chain. So we now need the product team, the marketing team, like all of the people that are thinking what to build, for whom to build, why it matters, like what specific problems we're going to solve. Those people are going to be like the bottleneck for the whole process. We can build it a lot faster, but if we don't have the requirements and the business definitions and the business logic from the product team, this is going to be wasted. So yeah, the bottlenecks move uh, up in the chain to the definition of the product, and at the end of the day, that's where the differentiation lives, right? It's the definition of the product what makes it different from another one. So yeah, with this democratization, like the differentiation moves upwards in the chain.
Last question here for you both. For those listening, specifically in technical leadership positions, are those who are potentially weighing significant build investments right now, what's the one question they should be asking, but they probably aren't?
I would actually piggyback on what Daniel just said. I think the question you need to ask yourself is what happens to everything else when engineering is no longer the blocker or the slow part, right? When you can build something really fast, um, how can you ensure that the rest of the process and the organization keeps up, right? Because if you look at how we traditionally build software, it is a slow-going pace over months to build something, which gives time for definitions to be sort of reiterated and decided upon, or for partnership agreements to be decided and signed and integrated into a backend or something, and for all of these other things, that all of those decisions that are made over time during the project suddenly need to be done upfront really fast, because you can't wait for the AI for the engineering, to deliver slowly the way they traditionally did, right? So I think that's the big challenge. Everyone keeps talking about, yeah, we can build so much faster now with AI. We can deliver faster, but can we? Because if you save 2 months, or let's say you deliver something 4 times faster engineering wise than you otherwise would do, but you only save 3 weeks in the end anyway, because you have so many other blockers and stuff that pop up that weren't done yet. I think that's the big challenge, and that's the question I would ask myself: how do I handle all of those things to ensure that we deliver faster the way we anticipated?
Daniel A., any closing thoughts?
Just agreeing on that last point. I think if you have to make a decision, it's not asking whether you can build it or how are you going to build it, because that's kind of solved now. So the question is, are we prepared upwards in the chain to define what we're going to build? And yeah, I think that's the key now.
Daniel A., Daniel E., thank you very much for your time. Really appreciate it.
Thank you. It's been great.
Thank you for the invite.
That's all for this episode. Thank you so much for listening. Big thanks to both Daniel Eneström and Daniel Astudillo. As always, really appreciate their insights. If you'd like to learn a little bit more about what we talked today, feel free to check out some of the links in the description of this episode, or stay tuned for us to publish Daniel Eneström's article around IBC time. If you're heading to IBC, feel free to check us out. Feel free to go to our website and book a meeting with us. If you have any questions, feel free to send me a message on LinkedIn or reach out to us at playbackpodcast@accedo.tv. That's all for this time. Thanks.